All right, here we go. So we're doing odd numbers. How does the increasing temperature increase the rate of a chemical reaction? Okay, so we're going to start our answer saying we are increasing temperature. So how does increasing temperature end up in an increased reaction rate? So we have to kind of take all of our steps to get to the right answer. So if we increase the temperature, that means that we are going to increase the speed, or you could say velocity, of the molecules, right? So what happens when we increase the speed of those molecules? Remember what happened when we increased the speed of the car? We ended up with a higher chance of collisions. So what is reaction rate? It's how much energy is in a collision, how often it can collide, and do we collide in the correct orientation, right? So if we increase temperature, we increase the speed, we increase our chance of collisions, and that results in an increased reaction rate. Okay. Let's look at B. How does increasing the amount of reactants increase the rate of a reaction? So let's do the same kind of thing. We're going to increase, and another way to say amount of reactants is to say concentration. That's what concentration is, amount of something. So if we increase the concentration of our, I'm just going to put R for reactants. What's that going to do? Well, the more reactant molecules we have, that's more molecules, we're going to increase our chance of collisions. It's all about collisions. And that is going to increase our reaction rate. Remember, this is like cars on the road. The more cars you have on the road, the more likely it is that you're going to get into an accident. Okay, let's see, we're going to go down. What does the rate of a chemical reaction, why does the rate of a chemical reaction decrease as the reaction progresses? Okay, so remember, if you have a reaction, it's going from reactants to products. You got to kind of remember that. So as the reaction progresses, what's going to happen? You're starting with reactants. So the reactants are converted into products, right? So if they're converted into products, are they around anymore? Nope. We've basically lost them. Okay, so as a reaction progresses, the reactants are converted into products, which results in a lower concentration of reactants. And we just talked about concentration's effect on reactants in the question above, right? So in this case, if we lower the concentration of reactants, now we're going to have fewer reactants or fewer reactant molecules, right? And if you have fewer molecules, we're going to have fewer collisions. If you have fewer collisions, that means you're going to have a slower reaction rate, right? So see how we kind of linked everything step by step. Okay, enzymes increase the rate of a biological chemical reaction by lowering the what? So remember, if you started out here and you ended up here, here was our normal reaction, but what happens when we add our catalyst? When we add our catalyst, we're still going to start at the same place, we're still going to end at the same place, but we're going to have a much smaller hill that we have to get over, a much smaller push that's going to have to happen to make the reaction go. So what do we call, if I draw a dotted line, from the maximum amount of energy input to that of the reactants, we call this the activation energy. So that's my answer right here is activation energy. So it lowers the activation energy. All right, let's see. Determine if the following changes in condition would increase or decrease the rate of chemical reactions in which they are involved. All right, storing leftovers in the refrigerator. If you put it in the refrigerator, you are going to decrease the temperature. If you decrease the temperature, what's going to happen? We're going to decrease the rate of a reaction. This is why bacteria don't grow in your food, or mold, or whatever it is. Other organisms can't grow in your food when you stick them in the fridge. I mean, they eventually do, but if you took the same food and you left one out on your counter and you put one in your fridge, like say a piece of bread or something like that, right? The one out on the counter is going to grow mold relatively quickly. The one in the fridge is going to stay in its normal condition without all that extra growth, right? Because of the temperature. So those cells that are trying to grow on your bread can't do it because all the reactions inside of the cells of the bacteria, of the mold, of whatever it is, are going so slow because they're in the refrigerator. So you decrease the temperature, you decrease the rate. All right, increase the kinetic energy of the reactant molecules. Remember, kinetic energy is movement, right? My little boy's got lots of kinetic energy. So the kinetic energy is really our temperature. Just think about, like, if you go for a run, what happens? You feel hot, right? You got a lot of kinetic energy. So you increase the temperature, that means you are going to increase, whoa, I gotta quit doing that. Here we are, and we increase the rate. Okay. Increase the frequency of collisions. So for whatever reason, however you get to that point, if you are increasing the frequency of collisions, the more collisions I have, one after another, after another, after another, not every single one's going to be productive, but the more collisions I have, the more productive collisions I'm going to have. So if I increase collisions, I'm going to increase my rate. So reaction rates are all about collisions. More collisions, more rate. All right, I think that's the last one. Yep. All right, that's the end of 5.2.